Let's understand how a p-n junction works, starting from the very beginning. Intrinsic semiconductor. Every silicon atom is bonded perfectly with its neighbors, forming a stable structure. At room temperature, only a few electrons gain enough energy to break free from their bonds. When an electron breaks loose, it leaves behind an empty space called a hole. These electron-hole pairs are the natural charge carriers in an intrinsic semiconductor. But their number is very small, so pure silicon is not very conductive. Extrinsic semiconductor. To increase conductivity, impurities are intentionally added. This process is called doping, and the resulting material is called an extrinsic semiconductor. Depending on the type of impurity added, we can create either an N-type or P-type semiconductor. N-type semiconductor. In an N-type semiconductor, pentavalent atoms like phosphorus are added. These atoms have an extra electron that becomes a free electron in the silicon crystal. So in the N region, electrons are the majority carriers, while holes are very few. P-type semiconductor? In a P-type semiconductor, trivalent atoms like boron are added. These atoms create holes which behave like positive charge carriers. So in the P region, holes are the majority carriers, and electrons are few. Formation of the p-n junction. When the N-type and P-type materials are joined, something interesting happens. Electrons from the N side diffuse toward the P side, while holes from the P side move toward the N side. As they combine, they leave behind charged ions, forming a central region with no free carriers. This central area is called the depletion region, and it acts like a barrier that opposes the movement of charge. Forward-biased p-n junction. When the battery's positive terminal is connected to the P side and the negative terminal to the N side, the diode becomes forward-biased. The external voltage pushes electrons toward the junction from the N side and pushes holes toward the junction from the P side. This reduces the width of the depletion region, allowing charges to cross the junction easily. As a result, current flows freely and the diode conducts. Reverse-biased p-n junction. But when the battery connections are reversed, the diode becomes reverse-biased. The positive terminal pulls electrons away from the junction, and the negative terminal pulls holes away. This widens the depletion region, acts like a strong barrier, and prevents current from flowing. Only a tiny leakage current exists due to minority carriers.